Number 16 has defined upside down solid triangle x to be equal to x plus 1 over x. Why? Because they felt like it for this particular problem. And we want to know, well, what if upside down solid triangle x is equal to t? Okay, so that just means x plus 1 over x, we want to know when that's equal to t, but x and t, according to the problem, both have to be integers. Okay, I'm going to kind of draw this out just so we can talk about a couple ideas that may be needed anywhere throughout the test. Let's see. So let's just go with A. Let's see if A works. If t were equal to 1, then you would have x plus 1 over x is equal to 1. And if I were to take this equation, let me change the blue here, and multiply the whole thing by x, I would get x squared plus 1 equals x, which would be x squared minus x plus 1 equals 0. Okay, so can I factor this? And if not, can I use the quadratic formula to figure out what kind of roots I would get? And again, I'm looking for integers for x. Well, I could actually just look at the discriminant from the quadratic formula, which is to say, look at b squared minus 4ac. Alright, so b is a negative 1 minus 4 times 1 times 1. So this is going to be 1 minus 4, or negative 3, which means I'm going to get complex answers, which I don't want, okay, because complex, we don't want it. And, okay, so b, if I were to let me change back to black for a moment. So if I were to let x plus 1 over x equals 0, and then multiply everything by x again, I would get x squared plus 1 equals 0. Now in this case I could just subtract the 1 to the other side, but now if I try to square root both sides, here I have to say plus or minus square root of a negative 1, but you can't square root a negative 1. That would be a complex number, which is not an integer. Okay, so b is out. So let's look at c. So now we want to say x plus, again, let me change to black. I just like changing colors. X plus 1 over x is equal to negative 1. And, okay, multiply everything by x. So x squared plus 1 equals negative x. Add the x to the other side. And if we look at the discriminant, so 1 squared minus 4 times 1 times 1 is going to be 1 minus 4, or negative 3. So again, I would end up with complex numbers. So I don't want D, or C rather. Alright, so what if we looked at D? Alright, x plus, I'm just going to stay in blue this time, and is equal to a negative 2. Multiply everything by x. So now you have x squared plus 1 equals negative 2x. Add the 2x to the other side. Now this is a perfect square. X plus 1 quantity squared. So to solve that, that means x would have to be negative 1, and negative 1 is an integer. So now I'm good. So D is actually what we want. Okay, so now let's just check out E and see why that doesn't work out. So E, x plus 1 over x equal to negative 3, everything by x. So x squared plus 1 equals negative 3x. Add the 3x to the other side. And if you check the discriminant, you would get b squared minus 4ac, which is going to be 9 minus 4, which is 5. Okay, now I'm not going to get a complex number, but since 5 is not a perfect square, in the quadratic formula, the entire thing, negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, this is what I've been calculating here. This is what we're calling the discriminant. Okay. So if I square root 5, well, that's going to be an irrational number. If you square root a prime number, it'll always be irrational. So there's no way my answers will turn out to be integers. And so that is why E is out. So again, D is the answer we're looking for.